Okay, in this recording, we are going to go through exam 2. I will review it with you just to help you out. So let us start. The function f of x is equal to x squared over 5 square root of x plus the cubic root of x over x. The question is to find the derivative, but now here I gave you a hint. I want you first to rewrite, and I didn't want you to use any quotient rule or actually not even a product rule. So the idea is just to learn how to rewrite this. So first let us rewrite it. F of x here can be rewritten as 1 over 5 x squared times x to the minus a half plus 1 x to the power a third times x to the negative 1. Now, of course, we're not going to keep it like this. We have to simplify it. So this will become 2 minus a half to the power 3 half plus x to the power minus 2/3. As you realize, once we write it like this is becoming actually fairly simple to find it. So now we find the derivative. That's very simple. We apply the power rule. So 1/5 is a constant. We drop it times the power x to the power 3 half minus 1 minus 2/3 x to the power minus 2/3 minus 1, which is going to give me minus 5/3. And then we can a little bit multiply here out. So this will end up giving me 3 over 10 square root of x minus 2/3 x to the power minus 5/3. Okay, so the whole idea here is basically that, to remind us that we can simplify sometimes expression as long as you simplify it correctly. Now, number 6 was you have h of x is tangent for x. I wanted to find the derivative. But in this problem, I wanted you to identify your inside function and identify the outside so that h will be f of g of x. So here, first, whenever we see tangent 4, remember we rewrite it as tangent x to the power 4. I mean, otherwise you will be confused with the meaning of it. So now my inside function is the tangent x, and my outside is u to the power 4. So with this way of writing, my function h will become nothing more than f of g. Now we need the derivative. The chain rule tells me that h prime is the derivative of f, but you evaluate it at the inside times the derivative of the inside. Now, the derivative of f is 4u to the power 3, but we evaluate it at the inside, so will give me 4. The inside is the tangent x to the power 3 times the derivative of g. So g is the inside function, which is tangent. Derivative of tangent is secant square x. Okay, so almost everybody in class did it correctly. It's just a matter of finding the derivative. So by using the quotient rule, so that was a simple one. We have to use the quotient rule to find g prime of x. And once we find g prime, since I wanted it at g prime 1, you plug in 1 for x into expression of the derivative. So this problem, I won't do it because it is actually simple. Now, let h of x be equal to the square root of cosine 1 plus e to the cx. I want the derivative. All right. So first we rewrite, because as I said several times, that derivative doesn't like the square root. So we will rewrite it as 1 plus e to the cx. That's h prime. Sorry, that's h. Okay, now h prime. That's definitely the chain rule. This is my inside. That's the inside. X to the power a half or u to the power a half, that's the outside function. So what is h prime? is the derivative of the outside which is a half to the power a half minus 1, evaluated at the inside function. You multiply this by the derivative of the inside. Now, the first term would leave me with, this is a half to the minus a half, and this is nothing more than that, times. Now, what's the derivative of cosine? 1 plus e to the cx. That's again, we have an outside here and we have an inside here. So that's another chain rule. So the derivative of the outside is minus the sine, 1 plus e cx. That's the derivative of the outside. So derivative of cosine is minus the sine, but you evaluate it at your inside, and we multiply this again by the derivative of the inside. That's why I call the chain, so we keep doing it. Now I think we are at the end of our chain, so it's going to be equal to, let's say half, and this is going to remain the same, so this will go here, times, this is remaining because we're done with that, times. Now what's the derivative of 1 plus e to the cx? 1 is a constant, derivative is 0, plus e to the cx, again I have an inside here. So this is my inside function. So the derivative of e to the cx is the derivative of the exponential, which is e to the power cx, times the derivative of the inside, which is c, and of the problem. Okay, so that's the chain rule of used several times. Right. So now the second page. Okay. Let's see here. So we have the function f of x equal. Now a lot of you had trouble with that problem. E to the 2x times g of x. So that's f. And I gave you some information about g, and I wanted you to find f prime at 1. So if I wanted to find f prime at 1, first you have to find f prime for any x. So what is f prime of x? Now watch very carefully, and that's where a lot of you messed up. That's a product. That's one function multiplied by another one. So the only way I can find the derivative, I have to apply the product rule. So that's e to the 2x, the derivative of the first times the second, plus the first times the derivative of g. So this is first product. So now the derivative of e to the 2x, that's 2x, that's my inside function. So it's the derivative of the outside times 2 times g of x plus e to the 2x g prime. That's f prime of x. Now I need f prime at 1. Means I need x to be 1. So if x is 1, it means I have to plug in 1 for x everywhere there is x. Not, I don't pick and choose. Everywhere there is an x, I plug in 1. So it's going to give me e 2 times, that's 2 square, times 2 g of 1 plus x is 1 times g prime of 1. And now that's where I gave you a bunch of information. So now let us substitute. I will get, that's 2e squared, g of 1 is 12, so times 12, plus e squared, and g prime of 1 is 2. And then I will get 24 from here and 2 from here. I will get 2 e squared. End of the problem. So go over it. My memory is that a lot of you messed up. Mainly they messed up in using the product rule. They forgetting about product rule. All right, now here problem number 6. So find the value of x for which the tangent line to the graph, so that's a function. Actually, if we graph it, we're gonna get x to the power 4/3. So it's gonna be something, I think it will look like something like that. Okay, that's the function. But we have to find the point on the graph where the tangent line is parallel to y equal ax plus 3. So let us say this is the line ax plus 3. That's the line. The question is, I want to find the point where the tangent line is parallel to this line, which means I have to find a point where the slope of the tangent line is equal to 8. So really the problem is we have to find the value of x such that the slope of this tangent line, it means the derivative of f at x, is equal to the slope of the line 8x plus 3 is equal to 8. So really the problem is boiling down to find for which value of x the derivative is equal to 8. Now we evaluate the derivative. So that's the function is, I know it's not very clear on the screen, but you guys have the exam. So you should know that's my function f. That's my f. So my derivative is 3 times 4/3 x to the 4/3 minus 1 equal to 8. And I need to solve for x. This cancel each other out. It means x to the power a third. I divide by 4 equal to 2. I need to solve for x. I take both to the power 2. This is going to give me equal to 8. It means at x equal to 8. Now, it's just pure coincidence that those are the same thing. That's nothing to do with the problem. So it means if I take x equal to 8 at this point, I evaluate the slope, I will get a line, tangent line that is parallel totally to the line ax plus 3. Problem number 10, we have a function, and I need to find the equation of the tangent line at the point 1 f of 1. Now, as I said, I don't have to give you f of 1. I only give you at a equal to 1, and we should be able to proceed. So the equation of the tangent line. All right, what's the equation? To find the equation of anything, I need, so equation of the tangent line. I need the point on the tangent line, and I need the slope. The slope is whatever the derivative is at this point, 1. And the point is 1 f of 1. Okay, so to find the slope, I need to find the derivative at 1. So let's go there. To find the derivative at 1, I have to find the derivative for any x. So this is my function f. The derivative is nothing more. We're going to use the quotient rule. Derivative of the numerator times denominator minus the numerator times the derivative of the denominator, the whole thing divided by the denominator square. That's the derivative for any x. What I'm interested in is the derivative at the point 1 f of 1. That's the slope that I need. So I evaluate the derivative at the point 1. And I get the following. X is 1, so I will get e times 2 plus 1, that's a 3, minus e times 2 over 2 plus 1 square. So this would give me 3e minus 2e, it's in e, divided by 2 plus 1 over 9. So that's the slope. Now I know the slope. So the slope here, whatever the graph is, so the slope is e over 9. That's the slope. Now the point. So the point is 1 f of 1. So let us compute f of 1. F of 1, it means that's my function. So it's in e over 2 plus 1, which is a 3. That's f of 1. So now here is the equation, the tangent line. So the point is equal. The slope, e over 9. The point is 1 f of 1 which is E over 3. Equation of the tangent line. All right. So every question here is a candidate for an exam question. All right, number 7. Find all the values of x for which the graph of the function have a horizontal tangent. So by now we know that what we're looking for are the critical point, because we're looking basically at those points where the derivative is equal to 0. So we were basically training ourselves for the critical point. So I need to set f prime equal to 0, and so for x. Very good. Now what is f prime? F prime is 6x squared plus 6x minus 20. This is equal to 0, and we have to solve. And solving, remember, it's factoring. You know, when we can factor, we can usually solve. So that's a quadratic that I would like to factor. Now, obviously, the first thing, you can either divide by 6 or factor out the 6, whatever you want. So we can factor out the 6 because this will make it easy now. And then I factor out the inside. 2 should give me 2 and 1, x and x, and that should be plus minus. It means that we have a horizontal tangent, or basically the critical point, occur at x equal to 1 and at x equal minus 2. Okay. So we've done a lot like those. Oh, I did a stupid mistake, sorry. This should be a 20. If this is a 20, so this should be plus 5. My apology. And this should be, so 20 should be a 4. And since I have the plus, so it's going to be x equal minus 5 and x equal to 4. Okay, sorry for the stupid mistake. Now 12. 12 is basically to remind us the definition of the derivative, where it came from. So here in the first part, I asked you just find f prime of 2, just the way we do it. And the second part, I wanted you to do the same thing, but use the definition. And of course, the answer have to be the same. So first, f prime of 2. So let us remember, this could be written x to the minus 2. So f prime of x is minus 2 x to the minus 3, or minus 2 over x to the power 3. It means the derivative at 2 is minus 2 over 2 to the power 3, which is 8, which is minus 1 over 4. Now, the second part, and this is to remind you, I wanted you to find the derivative, but again, using the definition as limit of slope of secant line. Because remember, the way we defined the derivative was like this. Suppose you have the function 1 over x squared. This is a graph. That's the point 1. And the way we defined the derivative was like this. We took those lines, what we call the secant line. So we fixed the point 1 right here. And then we took 1 plus a little h. And then we found the slope of this line. And then we let h take smaller and smaller values. And those slopes, then we have the slope of that line, then a line even closer to the point 1, and the limit of those slope is what we called the slope of the tangent line. So the slope of the tangent line is, by definition, equal the slope of those secant line. And the secant line, this is the point 1, f of 1. And this is the point 1 plus h, f of 1 plus h. And the slope is f of 1 plus h minus f of 1 over h. That's the slope. And then we see what happened to them when h takes smaller and smaller value. And that's really what the derivative is. That's what I meant by slope of secant line. So this is the slope of the secant line, the line we see right here. And we're asking ourselves, when h become smaller and smaller, what happened to those slopes? Now we're going to substitute verbatim and then find this limit. Okay, what is f of, So this is 1 over the quantity minus 1 over 1 square divided by h. Now I need to find the limit. It's equal to limit as h goes to 0 of. I need a common denominator in the top. It's going to be 1 plus h squared. So I will have 1 minus 1 plus h squared divided by 1 plus h squared. Okay, so this is going to be equal to the limit as h goes to infinity of. Now dividing by h like dividing by h plus 1. So it's like multiplying basically 1 plus h just to get rid of that term. And here I will have 1 plus h squared. And I need to find this limit. So I'm going to expand the top. And this would give me, let me expand it here. So it's give me 1 minus 1 plus h squared is 1 plus h squared plus 2h. So it means 1 minus 1 minus h squared minus 2h. So those will cancel each other out. I will have minus h squared minus 2h. Very good. Now we're going to factor out the h in the numerator. Actually, I can factor out the minus h here, which leave me with the h plus 2 over 1 plus h squared times 1 over h. And finally, h and h simplify. And then, sorry, we need the limit. And then when h goes to 0, what will happen? I will have minus f prime, this is a 2 here because I need f prime at 2. You know, in class you could have corrected me. Now here nobody to correct me. So minus 1 over, okay. I don't want to record again, so I'm going to do this problem again. I'm sorry about that. So I'm going to do it again because I was computing the derivative at 1 instead of 2. So I will repeat it then. It's the limit as h goes to 0 of f at 2 plus h minus f of 2. It's the same thing, but I'm going to do it at 2 divided by h. So my apology for the stupid mistake. So this will be equal to the limit as h goes to 0 of f of 2 plus h is 1 over the quantity 2 plus h squared minus 1 over 2 squared divided by h. Okay, so as I did before, I'm going to find a common denominator in the top. And the common denominator is going to be 2 plus h squared times 4. And that will give me 4 minus that. All right, so it's the same thing, but I just did a mistake and I put 1 instead of 2. So finally it is equal to the limit as h goes to 0 of divided by h is like h over 1. So I'm going to multiply by 1 over h here, and here I will have 4 times 2 plus h squared. And now I'm going to take this term in the top and expand it a little bit. So I'm going to distribute. I will have 4 plus 4h plus 4 plus h squared. All right, so let's do that. 4 minus 4, they cancel each other. I'm going to have minus 4h minus h squared. Okay, so now we will factor out the h or the minus h if you want. We'll be left with 4 plus h here and 2 plus h squared times the 1 over h. Now this h and this h cancel each other out, and I will be left with the limit as h goes to 0 of 4 plus h over 4 times 2 plus h squared, and that is my minus. And now when h goes to 0, what will happen? this goes to 0, this goes to 0, I will have minus 4 over 4 times 4, which is minus 1 over 4, which is, of course, exactly what we got right here. And honestly, when I realized I'm not getting minus 1 over 4, I knew I'm doing something wrong. And then I realized I'm taking the wrong point. Okay, so that's minus 1 over 4. So the goal of this problem is actually to remind you the definition of the derivative, that it should be actually kind of drilled in your head, but I know that we may forget it. So it is slope of secant line, what happened to them when h becomes very small. Okay, now let's see here. Let us say, suppose f of 0 is pi over 4, f prime of 0 is 3, and that h be sine square of f of x. Find h prime of 0. All right. Okay, so let us analyze this. So what is h of x? As I said, the minute I see sine square, I rewrite that sine of f of x, the whole thing to the power 2. So what is the derivative? Equal to. This is the chain rule, because that's my inside to the power 2. So the chain rule tells me it's equal to the derivative of the outside. So the outside is the u square. The derivative of the outside is 2u, but we evaluate it at the inside function. It's so 2 times the sine of f of x times the derivative of the inside. That's the chain rule. All right, now let us keep analyzing that. It's equal to 2 times the sine of f of x times. Now what's the derivative of sine of f? Again, we have an inside. That's my inside function. So I have the sine of something. So the derivative is going to be the derivative of the outside, which is the cosine of f, times the derivative of the inside. That's the chain rule over and over and over. Now h prime at 0, we need to find h prime at 0. Means we have to substitute 0 for x everywhere. So this will give me 2 times the sine of f of 0 times the cosine of f of 0 times f prime at 0. Now I substitute because I gave you the value. 2 times f of 0 is pi over 4. The sine of pi over 4 times cosine pi over 4 times f prime, which is 3. Okay. Now sine pi over 4 is square root of 2 over 2. And this is square root of 2 over 2. So this is times square root of 2 over 2 times the square root of 2 over 2 times 3. And now square root of 2 times square root of 2 is 2. So I'm going to have 3. End of the problem. Okay. Number 11. The problem number 11 is probably you have forgotten this a little bit. So let us do it. Let's do this problem. And I think I need a pencil now. Right. So here, that's the graph of a function f. And the question is, we have to sketch the graph of the derivative f prime. So let us see how we're going to do that. We start with this function. Now, the derivative doesn't exist here because the slope from the right and from the left definitely do not agree. There is a corner. And the derivative doesn't exist here. Again, for the derivative to exist, the function has to not have a corner. Because when it has a corner like this, if I compute the slope of the secant line from the left and slope for the secant line from the right, they are not equal to each other. So there is no derivative. So let us evaluate those. Right. So down here, I'm gonna sketch f prime. So this is my f, and this is f prime. Okay, up to -3, let's see what's happening. Up to -3. My function is a line, straight line. Means if I take any point here, right here, the derivative is nothing more than the slope of this line. Now, if you compute the slope of this line, you guys know how to compute it, we get -1/2. Okay, just pick any 2 points and compute the slope. So this means that up to -3, the derivative is -1/2. And at 3, it's open because there is no derivative at 3. It's just purely open. Now, all this happened till right here. Between -3 and -1, again, the function is a line. And so the derivative, remember, if a function is a straight line, it means f of x is, let us say, mx plus b. The derivative is the slope of the line. Okay, that's what it is. So this is -1 right there. The slope here is positive, and if we pick 2 points, I think the slope is going to be equal. We go up 1 here, we're going a little bit more than 2, so actually we're going 1, 2, 3, a little bit, almost 7/2. So from here to here, the derivative does not exist at -3, but then the derivative is constant. It doesn't change. The function change at a constant rate. At -1, we don't have derivative. That's open because we have a corner. Now, from -1 up to here, the function not changing. So the derivative is 0. Because if you take any 2 points, f of 1 plus h, whatever, f of x plus h minus f of x is 0. There is no change in the function. So this is going to be equal 0. So it's open in here. And right here, it's open, and the function is, the derivative is absolutely 0. Finally, the last piece here, again, that's a line. And the slope, again, you compute, if you go 1, you compute 1.5. So the slope is negative, and it's like -3/2. So it means from here to here, actually, how much it is here? Here, if you go almost, yeah. So the derivative here is somewhere in here. It's constant. Okay, so the goal of this problem is to sketch the derivative and also to remind you the fact that if a function is linear, this derivative is nothing more than the slope of this line. If it's constant, the derivative is 0. The function is not changing. The derivative is the slope of the secant line, and it's basically what we call the average rate of change. It means it's the change of the output minus the change of the input over the change of the input. That's really what it is when the change of input is very small. So if the function does not really change, of course, its derivative is equal to 0. Now let's look at another function. This one, sketch the graph of f prime. All right, this is there is no lines in the picture, so let's see how we're going to sketch the graph. All right, the way we do those, let's see, I remember how we do that. First, there are points which are very important. Like here, at this point, and this point, the derivative did not exist because of the corner. Right here, we're going to look at something different. Right here, we're going to say that we're going to pick up the point when the derivative is 0. And the derivative is 0 at the local max and local mean, right here. That's when the derivative is 0. That's where the slope of the tangent line is 0. So I immediately go down here and I put those because here the derivative is 0. Those points really guide us tremendously. Now, up to here, what's the derivative? Let's watch carefully. The function is decreasing. So those slopes are negative up to 0. And how they are negative? At the beginning, if you realize the slope are almost zero, so f prime here is negative. That's really the important part, okay? Because the function is decreasing. And let us see, at the beginning, it's negative, but at the beginning, the derivative is almost zero, as you realize, but then it gets more and more negative, then it switch and become less and less negative to be zero. So at the beginning, the derivative is zero, right there, and then it's negative, it's getting more negative, and then it's becoming say negative, but less negative and head towards zero. Okay, because at some point here, basically at the inflection point, right here, which is, this is my inflection point here, where the change concavity, that's what the derivative is doing. So it's getting more and more negative. At this inflection point, it's starting to become less and less negative. Now let us keep going between -2 and 2. My function is increasing, my derivative is positive. But that's not enough. We have to do more than that. How is it positive? At the beginning, let us realize it's getting more and more positive. At some point, right here at the inflection, it's becoming less and less negative and heading towards zero. So it's becoming more and more positive, and then right here is becoming less and less positive, heading towards zero. It doesn't really stop. So that's the derivative. Now, here we are. Then after that, the function is decreasing. And my derivative is negative, getting more negative, and then at some point it's starting stay negative, but becoming less and less negative, and it almost straightened. So it's negative, and it's becoming more negative, and then right here, almost right here, it starts to become less and less, stays negative, but less and less negative, and heading towards zero. And that's the graph of f prime. So let us recall. To sketch the graph of f prime, step number 1, you basically ask yourself when the derivative does not exist, that's what we did in this problem, or when is the derivative 0, or a combination. Okay. In this problem, the function, there is no corner, so the derivative is always there. So we only look at when the derivative is 0, and the derivative is 0 here, and the derivative is 0 right there. Okay, and then I take it piece by piece up to here. How is the derivative behaving? The function decreases, the derivative is negative. But now we look a little bit more. How is this negative? At the beginning, the function is flat, so the derivative is almost 0, and then it's getting more negative, but then it changes, it becoming less negative. And it changes where the concavity actually changed. That's really where the change occurred. Prior to before the inflection, it's getting more negative, and after that, it's becoming less negative. So the change really happened at the inflection point. And the same thing happened here, and the same thing happened here. So go over this problem carefully so you guys can remember how we did that. Now the last problem in the here is about implicit differentiation. And the main idea in the implicit differentiation is actually to remember that the y is a function of x, but we don't really know the formula. But we have to think about it this way. So how the implicit differentiation works? We say, okay, for every, that's what I have. Is equal to 0, okay? So we say, okay, this is not actually a y in my mind. This is a function of x, but I don't know it. So I say, if this function equal to that, the derivative, remember, d dx means the derivative with respect to x of that is the derivative with respect to x of 0. Of course, derivative of 0 is 0, so that's that. All right, now let's differentiate. 2y squared, derivative of that, it's 2 times. Now, again, this is not a y. This is a function of x. So now if I have a function of x and I square it, the derivative is 2 times f times f prime. So the derivative of y squared is y times y prime. Remember, y prime, another notation for it is dy dx. So you can either keep y prime or write dy dx. Sorry. No, minus. Now, here, you have to be careful. That's the product of two functions, one times another. So for find its derivative, I have to open my parentheses and apply the product rule. Derivative of x is 1 times y to the power 3 plus x times the derivative of y to the power 3 back to this scenario. But I have f of x to the power 3 here. So the derivative is going to be 3 f of x squared times f prime. So it means that's going to be 3 y squared times y prime minus derivative of x is 1 equal to 0. And now I need to solve for y prime. That's what dy dx is. I need to solve for that. So let me a little bit simplify it because I need to isolate the y prime. 3x y squared y prime minus 1 equal to 0. Now we need to isolate the y prime. So I will put everything in y prime together. And the constant terms, I mean the terms that doesn't depend on y prime from the other side. Now I have to factor out y prime because I need to solve for it. And finally, I will get y prime equal 1 plus y to the power 3 divided by 2y minus x y prime. And of the problem. Now, find all the points on the graph where the x coordinate is 2. So this is my function. Y cubed minus x plus 2 equal to 0. So I want to find the point where the x is 2. So I put x equal to 2 into the equation. And I solve for y. So it's going to give me 2y squared minus 2y cubed minus 2 plus 2 equal to 0. It means 2y squared minus 2y cubed equal to 0. Now I need to solve for y. So I factor out. Remember, I have to factor. I will get 2y, and then I will have 1 minus y equal to 0. And then I need to solve for y. So I'm going to get y equal to 0 and y equal to 1. So the points on the graph will be 2, 0, and 2, 1. Right. So on the picture right here, it's 2, 0, and 2, 1. This point and this point. That's where the x coordinate is 0. Those are those 2 points on the graph. Finally, I'm telling you that the graph of the equation above does not intersect the y-axis. So this is the graph, and it doesn't really cut the graph axis. There is nothing like that. And I'm telling you, and I explain why. All right. Suppose whenever a function intersect the y-axis, if a function intersect the y-axis, intersected at this point of the intersection, the x component is equal to 0. So in this problem, if we set x equal to 0 in the equation, suppose we set x equal to 0, and then we try to find the y, then we will have 2y squared plus 2 equal to 0. So if I set x equal to 0, I will have 2y squared plus 2 equal to 0, but this term is never 0, because that's a positive term plus a positive term, which is equal to 0. So if I put x equal to 0 and I try to solve. So set x and solve for y, we get 2y squared plus 2 equal to 0. It means y squared basically equal minus 1, which is actually cannot occur. So there is no way I can have x equal to 0. There is no value of y for which the x equal to 0. All right, so that's a review for your second exam. The problems it's been a while since I graded that. The problems you struggled with, if my memory is holding well, where, let's see which one you struggled with. A little bit with C, but this was not a big deal. You struggled a little bit with the 10, with the use of the quotient of the chain rule. There were a little bit of issue here, so please review that. And what else you have difficulties? I mean, this is depend. Some students find, some other students know. I remember having problems with this because you guys are forgetting to use the product rule when it is needed. All right, with this, I finished the exam, the review for exam 2, and the best of luck. And tomorrow, today is Thursday, tomorrow Friday, and tomorrow we will go over exam 3, and then I wish you luck. Bye.